Planning a trip today feels remarkably like managing a chaotic spreadsheet. You bounce from Instagram for inspiration, to Skyscanner to price flights, to Airbnb for lodging, and finally to Google Maps to figure out if any of those locations actually connect to each other. Traditional online travel agencies exist purely for the point of sale. The moment your payment clears, their operational involvement ends. You receive a confirmation email, and the platform's responsibility to you effectively vanishes. This leaves a massive logistical burden on your shoulders. After the booking, you are the one calculating minimum connection times at foreign airports, factoring in rush hour traffic, and predicting if a red-eye flight will leave you too exhausted for an afternoon tour. Travel Creator Studio functions as a unified orchestration environment, a hybrid between a nonlinear video editor and a logistics tool. The system models the journey as a continuous workflow, linking the inspiration phase directly to real-world execution. Addressing travel anxiety at this level requires a shift in how trip data is structured. By moving beyond the storefront model, the software architecture can begin to manage the physical and temporal dependencies of a journey. The first step is replacing the static text itinerary with a strictly typed temporal ontology. Every event is instantiated as a stateful JSON object, allowing the software to read, analyze, and modify specific parameters in real time. This diagram shows the underlying structure, a multi-dimensional travel graph. Nodes represent events, flights, hotels, activities, connected by strict chronological rules and geographic distances. Live data feeds into these nodes. A hotel node becomes a container for real-time inventory and exact spatial coordinates. Because these nodes obey specific mathematical rules, the platform's temporal awareness engine uses interval algebra to validate the physical viability of a schedule. It verifies that one event ends before the next one begins, with the necessary buffer to move between them. The engine also factors in physiological toll. It calculates cumulative fatigue burdens by analyzing time zones crossed, direction of travel, and activity density to map out physical exertion limits. Embedding these biological limits into the data structure ensures the system avoids generating schedules that are mathematically possible but physically exhausting to execute. The AI integration moves past the standard text chatbot interface. It utilizes a supervisor multi-agent architecture built on state graphs, allowing specialized models to collaborate on a single itinerary. It starts with an intent parsing agent. When a user requests to move all outdoor activities to sunny periods, this agent translates the natural language into computational parameters and routes the tasks to the appropriate worker agents. The flowchart shows the task distribution. A supervisor splits the intent among parallel worker agents, like cost optimization and sustainability, operating on the same itinerary segment simultaneously. These agents execute deterministic, reversible edits directly onto the travel graph, shifting nodes based on real-world constraints. Constraining the AI to output structured edits against a mathematical graph minimizes the risk of hallucinations. The system cannot invent a fake flight because the graph rules require a valid, verified data source to instantiate a node. Even a validated schedule meets reality. A storm rolls in, or a train is canceled, and a static planning document instantly loses its utility. The platform manages this through an event-driven architecture. It ingests live webhooks, push notifications from airlines and transit authorities to monitor the operational status of every frame on the timeline. When a disruption hits this flight node, the system triggers a replanning cascade. It follows the dependency edges downstream, automatically updating the airport transfer and hotel check-in times to maintain the coherence of the trip. This autonomous response to real-world friction turns the platform into a persistent operations manager. It monitors and adapts the schedule as the trip unfolds. This architecture supports a three-sided marketplace. It provides the technical foundation for travel creators, influencers, and local experts to build and sell executable digital assets. Because the itinerary is modeled as stateful code, a creator can sell a template that is instantly interactive. A traveler can purchase a recommendation, apply their specific dates, and book every component through the platform. Executing a unified checkout for a multi-vendor trip requires complex payment orchestration to split funds among suppliers. The system must also manage the legal liabilities defined by the EU Package Travel Directive. By bridging the gap between creator-led inspiration and logistical execution, The platform transforms scattered services into a unified programmable travel system.